All right, good afternoon, guys. So our last topic in this unit is about parallel and perpendicular lines. So congratulations, you have survived your first unit in Algebra 2. This topic may seem kind of like, why would I put this here? Because that sounds like a geometry topic. But I think you'll see why here in just a minute. So first thing, I want you to make sure that you can identify what parallel and perpendicular mean. Okay, so I'm going to give you just a second. Think in your head, which one of these three pairs of lines, 1, 2, or 3, are parallel? Okay, hopefully you said number 1. These are your parallel lines. What do I know about parallel lines? Well, they never touch. They never intersect. Why do they never touch? Because they have the same slope. They're going in exactly the same direction, just like railroad tracks. If your railroad tracks are not parallel, you're going to have a problem, okay? Now, here's the question. Numbers 2 and 3, or options 2 and 3, both of those lines intersect. So which one is perpendicular? Hopefully you said number 2. What's the difference between number 2 and number 3? Well, number 2, those lines form right angles. Okay? In order to be perpendicular, lines have to form right angles. So number 3, if I asked you if it was parallel or perpendicular, you would just tell me that it's neither. Because they intersect, so they can't be parallel. And they don't form right angles, so they also can't be perpendicular. So here's the thing that I have to remember about parallel and perpendicular lines. It all comes down to the slope. Parallel lines have the same slope. That's why they never intersect. Sort of like how sometimes you know how people say that siblings, they're so much alike that they don't get along? That's what parallel lines are. They're so much alike that they never want to actually see each other. Okay? They have the same slope. Perpendicular lines do not have the same slope. Their slopes are what's called opposite reciprocal. And I'll show you what that means here in just a second. So parallel, same slope. Perpendicular has opposite reciprocal slopes. Okay, so with that in mind, example 1 says write the equation of a line that is A, parallel, and B, perpendicular to this line right here. Well, parallel and perpendicular, it all comes down to the slope. So the first thing that I'm going to have to do is I'm going to have to take the line 3x minus 5y equals 15, and I'm going to have to get it in slope-intercept form. I'm going to have to get y by itself. So I start by subtracting the 3x on both sides and get negative 5y equals negative 3x plus 15. And again, I don't combine the negative 3x and the 15. Those are not like terms. One has an x and one doesn't. Step 2 is I divide everything by negative 5 to finally get y by itself. So y equals, okay, 3 over 5 doesn't reduce, but two negatives do make a positive. So I have positive 3 over 5. 15 over negative 5, however, will reduce. That reduces down to negative 3. So here's an equation of that line that looks much nicer, okay? Y equals 3/5 x minus 3. So if I want a line that is parallel to that, all that matters is this right here, my slope. If I write a line that is parallel to that, okay, and we'll do parallel in another color. We'll do parallel in purple, since they start with the same letter. Okay, so for parallel, all that has to happen is I have to have the same slope. So y equals 3/5 x. You can pick any y-intercept that you want other than negative 3, because then it would be the same line. You can do plus 7. You can do minus 1,000. You can do plus 348 million if you want to. All that matters is the slope has to be the same. So there's an example of one parallel line. Okay? Yours, if I ask you to write a parallel line, could be much different than someone else's. But what has to be the same is the slope. What about perpendicular? Okay, and we'll pick a different color for perpendicular. Perpendicular have opposite reciprocal slopes. Here's what I mean by opposite. If the slope on my blue line here is 3 over 5, the opposite of that is negative 3 over 5. The reciprocal part means if the slope is 3 over 5 on the blue line, then on the red line, it will be 5 over 3. So opposite refers to the sign. Reciprocal means I flip the fraction. And then I can put whatever y-intercept I want to. So I'll pick plus 11. You could pick any number you want to. So what matters is the slope. There's one example of a parallel line. There's one example of a perpendicular line. As long as the slopes are right, it doesn't matter what y-intercept I put. Okay? All right, next example here. It says write the equation of a line that is parallel to the line y equals 1/2 x minus 5 and goes through the point 4, negative 6. Here's why that's important. They just gave me a point that my new parallel line has to go through. So you know how in the previous example I could have written like a million different examples of parallel lines? I can't do that here. I have to specifically write the equation of the parallel line that goes through the point 4, negative 6. So how do I do that? Well, they gave me a point, which means I've got to use my point slope form equation. Y minus y1 equals mx minus x1. What is my slope here? Well, if it's a parallel line, it's got to have the same slope as the line they gave me. So m is 1/2. Okay? Then I take the point 4, negative 6. That's my x1 and my y1. So I write down x minus, and then x1 is 4. I write down y minus, and then y1 is negative 6. Okay? So the first thing I notice, two negatives make a positive. If they ask me for point slope form, I'm done right there. That's point slope form. Okay? But most of the time, they're going to say, go ahead and get y by itself. So to get y by itself, to get it in slope-intercept form, I start by distributing my 1/2, and I get 1/2 x, okay, minus 1/2 times 4. Well, that's the same thing as saying what's half of 4. That's 2. Step 2, y is not quite by itself yet. There's a 6 being added to it. So to cancel that 6 out, I subtract it on both sides with its like terms. And I get y equals 1/2 x minus 8. Okay? So what I did is I found a specific parallel line that went through the point 4, negative 6. And then I'm done. All right, question 3 says this. Write the equation now of a line that is perpendicular to the line y equals 1/2 x minus 5 and goes through the point negative 2, 5. So again, they gave me a specific line that I have to find. It's the one that goes through the point negative 2, 5. So because they gave me a point, I use my point slope equation. What's the slope going to be this time if this line's going to be perpendicular? It can't be the same as the line they gave me. It's going to be the opposite reciprocal. So look at that slope. The one that they gave me is positive. So the opposite of that is negative. Reciprocal means I take that 1 over 2 and I flip it so that it's 2 over 1, which is just 2. Okay? Now I plug my point in. So x minus x1 is negative 2. On the other side, I do y minus y1 is 5. And again, I find two negatives, I change them to a positive. So if they want point slope form, boom, I'm done right there. But if they say to me, hey, put this in slope-intercept form, that means get y by itself. So I start by distributing. Negative 2 times x is negative 2x. Negative 2 times 2 is negative 4. My last step now is I have a y that's being subtracted by 5. To cancel out that subtraction, I add it to both sides wherever there are like terms. So y equals negative 2x. Negative 4 plus 5 is 1. And then you're done. So if I were to go graph the lines y equals 1 half x minus 5 and negative 2x plus 1, you see that they're perpendicular to each other. Okay? All right, and that is the end of our discussion on parallel and perpendicular lines.